my name is Myung Kim from class number 3 of Fundamentals of Semiconductor Devices, and I'm here to give a summary of the last week's lesson on the brief history of atom and the Bohr's model of hydrogen atoms. So first, there are four models of atoms throughout the history: Dalton's, Thomson's, Rutherford's, and most importantly, the Bohr's. I'll only give explanation about the Bohr's because of time, and there are three assumptions of Bohr's atoms. Okay, number one, electrons exist on a certain level. Yes. Number two, electron can move from a level to another level with energy transferring. The energy transferring can be represented by the equation of E equals the Planck constant times the frequency. To give explanation about the Planck constant, we must first know about the Planck's law. Now, I can only explain the brief bare bone concept of the law. So here it is. Like by radiation. Okay, the result emits radiation. Here's the result. The function radiation. The function of radiation. The function has a constant, which is the Planck constant. Now, the Planck constant has a value of 6.63 times 10 minus 34 joules per second. Now, the final assumption, number 3, the electron orbitals have angular momentum proportional to the integer and the radius. The angular momentum of the atoms can be represented by the previously mentioned Planck constant, which summed it up by L equals n integer times constant divided by 2 pi. The momentum can also be represented by the following equation: power equals mass versus mass times velocity. Now, combining these two results, we can find out the velocity of the hydrogen atom. V equals integer times constant divided by 2 pi mass and radius. Now, using the Coulomb force, I'll explain later. We can also find out the radius of the hydrogen atom. Okay, R equals Coulomb force divided by velocity powered, which results in the radius of the hydrogen atom. Okay, the Coulomb force between two particles are F equals the Q1's electric charge, Q2's minus Q, divided by the surface of the circle, and the permittivity of free space. Now, the Coulomb force of between two particles can also be connected with potential energy. F equals the minus gradient of potential energy, which if you integrate it on both sides, we can get these following results. Okay, potential energy equals the 0 minus Coulomb force, which as a result, the potential energy equals the Coulomb force.